Hello, we are the UCL team that will be working on extending the impact engine framework that the Green Software Foundation has been developing. We will be adding a new model which will perform parameter optimization using search-based software engineering. In this presentation, we will provide some background information on the importance of tooling to measure the environmental impact of software, a brief summary of the impact engine framework and the way it operates, along with an introduction to the functionality we will be adding.
Information and communication technology significantly contributes to carbon emissions and energy consumption worldwide. It is responsible for up to 3.9% of global greenhouse gas emissions and up to 3% of global energy consumption, with expectations of further increase in the future. Green computing, or green software, involves developing software and computing components to minimize their environmental impact while maintaining optimal performance. The aim is to reduce carbon emissions and electronic waste and promote the use of renewable energy sources. But how can this be achieved? To improve the environmental impact of technology, we first need a standardized method of measurement, which can be challenging given the increasing complexity of modern software applications. There is no industrial standard, as the few existing methodologies tend to be complex and are not widespread enough. This has been the motivation for the Green Software Foundation, as they wanted to establish formal standards and tooling, which led them to the development of the Impact Engine framework.
As Tama just said, existing approaches for measuring environmental impact are mostly proprietary for specific software with no public standards provided. This is partially due to the complexity of modern software, which operates with various subcomponents across diverse environments, such as containerization or virtualization. Under this complexity, alongside with other external factors like geographical location, it's unlikely to create a universal measuring algorithm. So the Impact Engine framework aims to provide an open source, easy to use, and extensible tool with a standardized interface, enabling everyone to contribute submodules for measuring different software systems. Users with any technical background should be accessible to this tool. The future work aims to focus on extending this tool instead of reinventing the wheel. Next, Fan will explain how the IEF tool works.
We see here an overview diagram of the process of using the IEF. Firstly, the user creates the input YAML file with configurations such as the system architecture, input parameters, and the models to use in the pipeline. Well, the pipeline is a series of models used, and they will run one by one according to the order specified. Models receive inputs either directly from the input YAML file or from the output of preceding models in the pipeline. And then the impact engine is triggered through its CLI command line interface. Each model will perform computations and output the results, passes on to the next model. Eventually, another YAML file is generated with all the output information and the measurements calculated. Next, I will be introducing the project goals as we have in mind about the model. The first goal is optimization. Our extended model should provide optimization suggestions to the users and visualize trade-off with different suggestions. The second goal is extensibility. The model should be easily extensible to accommodate future changes to the impact framework. And lastly, the third goal is for the model to be user-friendly. We want it to be able to be easily used by someone with no technical expertise.
Okay, as we move forward from understanding the goals of the model, let's turn our attention to the stakeholders. Firstly, we have the Green Software Foundation. The foundation's mission is to reduce the total change in global carbon emissions associated with software. Next, we consider software developers and the companies. These are the individuals and groups who are directly involved in software development. Our model serves as a tool for them to access and optimize the environmental impacts of their software throughout the development process. And then we have the open source community. Our model aligns with the ethos of transparency and community participation. As we delved into how to improve the impact framework, we focus on the key goals that would guide our way forward, like reducing the carbon footprint of software systems. However, we are currently facing a critical problem. The existing functionality of our framework does not actively provide users with feedback on how to improve. So this is where we see a significant opportunity. So imagine a model within the impact framework that does not just measure but also mentors. We are not just highlighting the areas for improvement, but also providing actionable feedback and strategies on how to reduce environmental impacts.
Having defined the goals and context, let's delve into how of our solution. In the vast space of potential solutions, our challenge is not just to find any answer, but the most advantageous one. To navigate this intricate space, we'll harness the power of genetic algorithms. These algorithms are inspired by evolutionary selection, where the best solutions survive and guide the next generation. Genetic algorithms excel at optimizing by combining exploration, which is finding new solutions, and exploitation, which is improving the best ones. Our use of genetic algorithms is rooted in UCL's significant contributions to automated software engineering. By integrating multi-objective optimization techniques, we'll not just seek a single optimum, but rather a spectrum of optimal solutions. This enables us to cater to various user-defined metrics, constraints, and requirements.
Now, let's dive deeper into the new model we're introducing. The model is designed to take in simple inputs such as available server locations, timeframes, and specific metrics for improvement. The goal is to explore different combinations of these inputs to produce the most environmentally friendly outputs. Using these input parameters, the model leverages search-based techniques such as genetic algorithms to iteratively search for more optimal solutions. After processing the inputs, the model will output actionable recommendations that help minimize environmental impact. This includes suggested server locations, operational timeframes, and choice of system architecture. Also, by identifying the Pareto front, the model aims to represent a set of different optimal solutions, each with their own trade-offs. Decision makers can then review these options to make informed decisions that align with their priorities.
Our evaluation and testing will be done using a Python tool, performing an exhaustive search of optimization search space and choosing the best combination of parameters. We'll compare that optimal combinations with the results generated by the parameter optimization model to test the correctness of the model. If the workload is too extensive, an alternative approach is to use sampling. The evaluation criteria focused on various aspects. The model must be flexible and adaptable to potential changes to the IF, as well as any enhancement with new models. The model must also be usable and easy to include into the pipelines. Performance will lastly be measured by examining the time overhead that is caused by including the new model into a pipeline.
In summary, the model we will be implementing tackles the problem of decreasing environmental impact of software directly by offering suggestions to optimize certain input parameters. It will use genetic heuristics to go through the parameter search space and provide feedback to minimize the environmental impact of this software instance. We will focus on making it parameterizable and extensible to be easy to integrate with new models and changes so that it continues to be useful in future versions of the Impact framework. This new model will add a lot of value to all current users of the Impact framework and is expecting to increase the user base as the new functionality will attract new users. Thank you a lot for your attention and feel free to contact us for any questions.